All right, welcome back, ladies and gentlemen. We've got this solving problem here using the quadratic formula, which, by the way, is negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Before I can plug into this formula, though, I need this to be in standard form. So I'm going to go ahead and do some algebraic solving. So subtracting 2x from both sides gives me 4x squared minus 12x equals negative 9. And then I'm going to go ahead and add 9 to both sides and get 4x squared minus 12x plus 9. And we have it in standard form now, which means I can plug everything into my formula. So my a value is 4, my b value is negative 12, and my c value is 9. Therefore, we've got negative 12 plus or minus the square root of negative 12 squared minus 4 times 9. And that's all over 2 times 4. Negative 12 is positive 12, plus or minus. 12 squared is 144. And then we have 4 times 9, which is 144. So this is minus 144. Or you have negative 4 times 9. That's negative 144. And that's all over 8. Well, like we saw in the last example, this becomes 0. So we have 12 plus or minus root 0 over 8. But we know that that's just making it 12 over 8 because plus or minus 0 doesn't do anything. So 12 over 8 is our answer. Or simplified, that becomes 3/2. And again, if you've got questions on this one, make sure you get those addressed before you move on to the final example, which is using the quadratic formula with imaginary solutions. Now, an imaginary solution, remember, is when we have the square root of a negative number, right? The square root of negative 1. So just to kind of look back at these other problems real quick, notice that in this problem, the root became 0. In the first example, the root became a positive number. In this final example, we're going to see what happens when that root becomes a negative number. And a negative number, the square root of negative 1, we always denote with the number I, right? It's called an imaginary number. More appropriately, like imaginary makes it sound like it doesn't exist, which is not the correct sort of interpretation of this. Complex number is probably the better way to say it because it's a number that exists, right? It's a number that we made up, but it's a number that exists. The square root of negative 1, right? We call that I. So let's go ahead and do an example, and we'll see what happens when that becomes that negative number. So again, we got to work with standard form, so I'm going to subtract 5 from both sides first. This becomes negative x squared plus 4x minus 5 equals 0. Now my a, b, and c, a is negative 1 because there's a negative there. B is positive 4, and c is negative 5. So when I plug into my formula, that's going to be, oh, by the way, my formula, I didn't write it down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. We plug into our formula, we get negative 4 plus or minus the square root of 4 squared minus 4 times negative 1 times negative 5. And that is all over 2 times a. So, or excuse me, 2 times negative 1. I don't know why I wrote a. So negative 4 doesn't change, plus or minus. This becomes 16. And then we have negative 4 times negative 1 times negative 5, which is negative 20. And that is all over negative 2. Now, notice that when we do this, we get negative 4 plus or minus the square root of negative 4 all over negative 2. Now, here is where we have to deal with the complex number. The square root of negative 1 is I. And the square root of 4 is 2. So when we simplify this, this will be negative 4 plus or minus 2i. The negative will always come out as an I, and the square root of 4 comes out as 2 like it normally does. And that's all over negative 2. And finally, our last step, notice that each of the 3 terms is divisible by 2. Therefore, we can reduce this. Actually, they're divisible by negative 2. So we can reduce this, and we make this negative 2 plus or minus I, because the 2 is gone, all over negative 1. Which, by the way, we don't need to have over negative 1, so we can just switch the sign there and make that 2. So there we go, our final answer. And so yeah, the big thing here, again, the quadratic formula works the same way. It's just that in the end, what's under the square root becomes negative, and then we have to change that negative to I being a complex number. All right, we got one more practice for you, and then a problem to do on your own. So we will see you in the last video in just a moment.